Title: Oafri Innovations. Quick visuals of a tomato crop and rows of corn. A man, Dale Cohen, inspects cornstalk leaves. A shovel lifts soil beside a plant, and a different man, Albert Tenuta, walks through a corn crop. The first man, Dale, adjusts a Spornado air sampling device. A female voice speaks off camera.
How do you detect diseases in crops before they become infected? Thanks to Oafri funding, one Ontario innovation may have found the answer.
Title: From Idea to Impact, Spornado. Christine White stands in her office. Christine White, CEO and co-founder of Spornado, speaks.
Hi, my name is Christine White, and I'm the CEO and co-founder of Spornado.
Title: What was the challenge? Images of different fields of crops. A woman, Amanda Tracy, walks through a row of crops and kneels down to inspect a diseased leaf with dry, brown edges on a tomato plant.
Fungal disease costs the ag industry a ton of money, yet growers don't know when disease is in the field until they see it and it's too late. There's a lot of guesswork involved currently with deciding when to spray. If growers fail to stop fungal disease, it can have a devastating impact on the crop. It can reduce yield and it can impact quality.
Quick visuals of Amanda Tracy walking through fields and inspecting crops, a pepper growing, a hand feeling soil, and Amanda taking notes. Amanda Tracy, Ontario vegetable crop specialist with OMAFA, speaks.
Some can be more aggressive than others and cause complete plant death. Some may affect the fruit and get unmarketable or make it so people don't want to buy it. Well, essentially, if you're spraying a crop too early, you're kind of wasting your money and you're wasting an application of your fungicide. We only get so many applications of certain fungicides on our crops, and making sure that we're timing them appropriately is really key to getting good disease management.
Title: How did you innovate? A woman tests Spornado air samples and takes notes. Old Spornado prototypes are shown, followed by the current Spornado device installed near a crop. Christine White speaks.
So the co-founders and I, we had been working doing indoor air sampling for fungal pathogens for many years. And I got a phone call from a crop protection company actually that was looking for a simple air sampler that farmers could use outdoors. We were shocked there wasn't one. So we designed the Spornado.
A hand inserts a disposable cassette into the Spornado device. The Spornado rotates as it blows in the wind. A pile of disposable cassettes are shown on a table. Mike Saleh, CTO and co-founder of Spornado, speaks.
The Spornado is a passive air sampler that gets installed in farmers' fields. It stays out there 24/7, sort of sampling the air and catching fungal spores on a disposable cassette.
A lab worker inspects a cassette and takes notes. Test tubes are pulled out of a circular machine, and a small plastic baster is inserted into a set of test tubes. Amanda Tracy speaks.
So we come out to the field, we collect cassettes twice a week, and then we put them in little bags and we ship them off to the lab in Toronto. And then they run it through and look for DNA for the disease that we're looking for.
Title: How did government support help? Mike Saleh and a team of scientists analyzed spore samples in a lab, taking notes, spinning test tubes in a round device, and looking at cassettes. Two graphs on the computer are shown where they're entering data. Christine White speaks.
Some of the ways that we used the funding was to develop new tests for new diseases in the lab, to get trials going in the field, and also to optimize our data collection database. With this funding, we did trials in grapes, strawberries, apple, and we're now doing trials in wheat, corn, and soy.
Wheat and corn are shown, followed by a chart in the lab depicting different microscopic pathogens. A woman opens a container in the lab, pulls samples out of a freezer, and places test tubes in a holder. A man inspects the leaves and silk on a cornstalk. Mike Saleh speaks.
Being microbiologists in a lab, we don't know what are the biggest concerns for the growers out in the field in real life. And the OMAFA researchers really kind of dialed that in for us and said, our growers are really facing these problems with these diseases, and then we could kind of focus on those and grow faster.
Title: What's the potential impact? Quick visuals of crops followed by a Spornado device in a soybean field. A man, Dale Cohen, looks at a computer screen with disease risk models shown over a map. Albert Tenuta, Ontario field crop pathologist with OMAFA, speaks.
So this technology fits well into our decision support tools that are available now and in the future, whether it's disease forecasting, modeling, etc., that depend on the weather. Having a good understanding of what's going on with the disease and ultimately the presence of that disease will make these support tools better, save yield, and ultimately reduce disease losses.
Hands hold a phone with disease data on a map, and then a man, Dale Cohen, inspects a plant with yellow, speckled diseased leaves. Dale talks to a grower in front of a field of soybeans, looks at disease risk data on his tablet, and adjusts a Spornado air sampler. Dale takes a round plastic cassette out of the device, walks through the field, and scans the cassette with his phone. The grain silo and tractors for the farm are shown. Dale Cohen, Agronomy Strategy Manager and Senior Agronomist at Agrees Cooperative, speaks.
So our GrowMark technology from Bloomington, Illinois, comes to us as an integration of a number of important modules that bring in field-level data, such as planting data and hybrid. So we're testing the Spornado technology this year. We have it strategically located throughout our territory, plus we're sharing other trapped information with other locations. If we do get a high risk level or we're working with customers that do want to spray a fungicide, we're asking to leave an untreated check strip so we can verify the yield response from the fungicide application.
Title: What's next? Quick visuals of crops, a foot pushing dirt around the base of a pole, a pathogen chart, a cassette going back into a Spornado device, a fan spinning inside the air sampler, hands typing on a laptop, disease tracking graphs, Amanda in the field, Mike and the team in the lab, Dale in the field, and a Spornado cassette. Christine White speaks.
We're developing an in-field real-time sensor. We are working on developing tests for a variety of different fungicide-resistant strains. We're using our data along with AI-powered models to predict disease. The seasonality of agriculture means that innovation isn't fast. It can be quite slow and quite expensive, and having the funding really helps with that.
Amanda, Albert, Dale, Mike, and Christine are all shown standing proudly inside their workplaces. A female voice speaks off camera.
Innovation doesn't end at research, and thanks to government support and expertise, this Ontario-made technology has now been used in 25 countries.
Learn more at ontario.ca/agresearch. Logos appear for the Sustainable Canadian Agricultural Partnership, the Government of Ontario, and the Government of Canada.